Come along for the ride.
Welcome to the Solar Coaster, the wild ride to the solar industry told by the people living it every day. I'm Anna Covert.
And I'm Alex Herrera.
Think about the electric grid for a moment. For nearly a century, it was arguably one of the most stable, slow moving pieces of infrastructure on the planet. It was all about physical hardware, poles, wires, massive coal plants, and simple analog meters. But today, that picture is unrecognizable. The grid has transformed into a highly connected digital ecosystem driven by solar power, battery storage, and smart management systems. And with this massive shift, a hidden battleground has emerged, one fought not with steel and concrete, but with intellectual property. Why is patent litigation suddenly becoming a major headache for the clean energy sector?
It comes down to complexity. In the old days, power flowed in one direction from a central power plant down to your home. Today, with rooftop solar, utility scale solar farms, and battery storage systems, power flows in every direction. Managing that requires incredibly sophisticated software, edge controllers, and communication networks. Because this technology is so new and valuable, companies have spent the last 2 decades quietly filing patents on how these systems talk to each other and manage electricity. Now, we are entering a phase where those patents are maturing, and it is creating a very crowded, high-stakes legal environment for utilities and developers alike.
So this isn't just a future risk, it is actively happening right now. It sounds like we are seeing the convergence of two distinct trends. You have the older foundational smart grid technologies, and then you have this new wave of artificial intelligence and machine learning. How do these two waves interact?
That is exactly the right way to look at it. The first wave started in the early 2000s and peaked around the mid-2010s. This wave was all about the physical and digital foundation of the smart grid, things like advanced metering infrastructure, remote meter reading, and basic communication protocols. A lot of those patents were granted 10 to 15 years ago. In the patent world, that midlife period is when things get interesting. The technology has matured, the market has adopted it, and patent holders realize this is the prime window to monetize their intellectual property through licensing or enforcement before the patents expire.
It is like building a toll booth on a highway after everyone has already started using the road. If you try to collect tolls before the road is paved, no one cares. But once it is the main highway for the clean energy transition, suddenly those patents are incredibly valuable.
Exactly. And just as that first wave is reaching its peak commercial value, we are seeing a second wave crash right on top of it. This second wave is driven by artificial intelligence and machine learning. Instead of just collecting data from a smart meter, companies are now using AI to predict weather patterns, forecast solar generation, optimize battery discharge rates, and manage local grid stability in real time. These AI-driven patents are being layered directly onto the older smart grid infrastructure.
Which means even if a developer manages to navigate the legacy patents, they might still run straight into a wall of newer AI-related patents. Let's break down what this actually looks like in practice. If you are a utility-scale solar developer or a company setting up a virtual power plant, where do the actual risks lie?
The risk lies in the overlap between everyday operations and patented methods. Take dynamic rate structures, for example. To make dynamic pricing work, you need real-time data on energy production and consumption. If a utility deploys a new platform to analyze this data and adjust prices, they might be using algorithmic methods that are already patented by a software vendor or a competitor. The same goes for virtual power plants where you coordinate hundreds of individual home batteries to act as a single power source. The control strategies, the communication loop, the forecasting models, almost every step of that process is a candidate for patent protection.
It sounds like a minefield. If you are a developer buying equipment and software from third-party vendors, you might assume that the vendor has cleared all the rights. But that is not always the case, is it?
Not at all. Often vendors sell a product, but the way the utility integrates and uses that product within their specific grid architecture is what actually triggers the patent infringement. Or the vendor itself might get sued, which can disrupt the utility's operations or lead to costly supply chain delays. This is why we are seeing a shift in how these projects are negotiated. It is no longer just about the price per megawatt or the efficiency of an inverter. It is about who bears the intellectual property risk if a lawsuit arises.
So, how do companies protect themselves? If you are a utility or a clean energy developer, you can't just stop deploying solar and batteries because of patent risks. The transition has to move forward. What are the practical steps to mitigate this?
The first step is proactive due diligence, specifically what lawyers call a freedom to operate analysis. Before rolling out a major new technology platform or grid initiative, companies need to work with legal teams to map out the existing patent landscape. You want to know who holds the key patents in the space you are entering. If you find a potential conflict early, you can design around it, choose a different vendor, or negotiate a license before you have invested millions of dollars in deployment.
That makes sense. It is much cheaper to adjust your software architecture during the design phase than it is to rewrite it after a cease and desist letter arrives. What about the contracts themselves? How do you handle vendor relationships in this environment?
Strong indemnity provisions are crucial. When utilities purchase smart grid software or advanced hardware, they need to ensure the contract explicitly states that the vendor will defend them and cover any damages if the technology is found to infringe on someone else's patent. But even then, indemnity is only as good as the financial health of the vendor. If a small startup sells you a revolutionary AI forecasting tool and then gets sued, they might not have the resources to cover your legal defense.
Which brings up an interesting strategic point. If you are a company developing these advanced AI tools for the grid, you shouldn't just be playing defense. Having your own patent portfolio can actually be a powerful shield, right?
Absolutely. In a crowded patent landscape, having your own intellectual property is a form of currency. If a competitor accuses you of infringing on their patent, but you hold patents that they might be infringing on, it often leads to a cross-licensing agreement rather than a protracted, expensive courtroom battle. It gives you leverage. Furthermore, protecting your unique algorithms and system designs creates tangible business value, making you a more attractive partner or acquisition target.
It is fascinating how the energy sector is starting to resemble the smartphone wars of the early 2010s, where tech giants sued each other constantly over software features. We are seeing those same dynamics play out in the power grid.
The comparison is spot on. The grid is becoming a giant computer, and just like the telecom industry, the winners won't just be the ones with the best hardware. They will be the ones who navigate the intellectual property landscape most effectively.
Looking ahead, this seems like a trend that will only accelerate. As the grid becomes more decentralized and more reliant on real-time data, the role of AI will transition from a luxury to an absolute necessity.
Definitely. We cannot run a high penetration solar grid without machine learning. Human operators simply cannot process the data fast enough to balance supply and demand when cloud cover changes or millions of electric vehicles plug in simultaneously. Because AI is essential, the patents covering these AI applications will become the most valuable assets in the energy sector.
It highlights the need for a cultural shift in the clean energy industry. Engineering teams and legal teams need to work hand in hand from day one. Intellectual property can no longer be treated as an afterthought or a line item handled at the very end of a project.
Exactly. It has to be integrated into the core engineering and business strategy. If you are designing a new control algorithm for a battery storage facility, the patent search should be happening alongside the initial coding, not years later when the system is already live on the grid.
It is clear that the transition to a clean energy future is about more than just solar panels and wind turbines. It is about the digital brain that runs it all and the quiet battle for who owns the rights to that brain. For developers, utilities, and technology providers, understanding this evolving patent landscape isn't just about avoiding risk. It is about securing their place in the future of energy.
I want a solar coaster. Come along for the ride.
This episode of The Solar Coaster is narrated using AI-generated technology, representing Anna Covert and Alex Herrera. The material presented is aggregated from publicly available solar industry news sources. All commentary reflects reported industry developments and does not constitute personal opinions, investment advice, or endorsements by the hosts or
Solar
producers.
Coaster is proudly sponsored by Sun Energy Today, redefining what solar means for business and infrastructure. We engineer and deliver large-scale clean energy solutions, from megawatt solar farms to advanced graphene storage, designed for resilience, performance, and measurable return. Sun Energy Today, built to power what's next. Learn more at sunenergytoday.com.